Hi, welcome back to our lecture. Now that you know a little bit about the EC2 service, let's spend some time working with EC2 in this hands-on segment. So I've already logged into the AWS Management Console, and I'm going to go to the EC2 Dashboard. When I get to the EC2 Dashboard, you'll notice that there are lots and lots of different features available in EC2. In fact, it's one of the more complex services that AWS offers. It's also one of the original services. So over the last 15 years or so, AWS has continuously added more and more features. Now, we're going to cover quite a few of these features in this course, but I'm not going to go into detail on every single feature that's available. And starting out, I'll keep it fairly simple. Let's start out by launching an EC2 instance. And so to do that, I'm going to click on the Launch Instance button. And the first thing that pops up is this wizard-like process that's going to kind of guide me through the process of launching an EC2 instance. And the first thing I have to do is I have to specify the Amazon Machine Image that I want to use for my instance. And remember, an Amazon Machine Image is basically like a template that contains an operating system, set of applications, and configuration. And all of these different AMIs that you see listed here, these are AMIs provided by Amazon. So these are curated AMIs. On the left-hand side, you can see these tabs where I can select other categories of AMIs. Like I can look at the AWS Marketplace or community AMIs, or if I have any private AMIs in my account, I could use those as well. I'm going to choose the very first AMI that's listed, the Amazon Linux 2 AMI, which is an AMI we're going to use quite often in this course. I'll go ahead and select that AMI. The next thing I need to do is I need to specify the instance type. And remember, there are several different types of instances that are available. And your goal is essentially to align the instance type with the needs of your particular workload. Now, in this example, I'm going to use the T2 micro instance type. And you see that there's this little badge that's next to the T2 micro name that says free tier eligible. What that means is that you can launch an EC2 instance using the T2 micro type, and it will qualify for the free tier. If you are a new AWS customer, you qualify for the free tier of services for the first year, meaning that you can then spin up this EC2 instance and it won't cost you anything, which is great. We'll use it just simply because it's a cheap instance. Even if we had to pay for it, it would be very, very inexpensive. So I'm going to select the T2 micro type and then click Next, Configure Instance Details. And on this page, I can configure many of the settings for the EC2 instance. I can specify how many instances I want to launch. If I want to launch 5 instances that are all configured the same way, then I could type in 5. But in this case, I just want to launch a single instance. I could request spot instances. And remember, spot instances allow you to essentially bid on EC2 compute instances using a market-derived pricing model. In this case, I'm going to just launch a standard on-demand instance. The networking will cover later in this course in great detail. So for now, we just want to leave the network settings the way they are. I could specify that this EC2 instance should belong to a placement group. I talked about those in the earlier part of the lecture, where if I want to physically sort of co-locate instances close to one another, I could do that. Capacity reservation allows me to reserve capacity for a certain amount of time. If I knew, if I was spinning up this instance and I knew that it was going to run for at least a year, then I would want to reserve capacity because I'm going to get a substantial price break for doing so. I could associate an IAM role with the instance. You'll learn a little bit more about that later on in the course. I'm just going to say that there's no role for now. With the shutdown behavior, I'm telling AWS what should happen if I shut down the server. In this case, the default behavior is just simply to stop. I could change that to terminate if that was the behavior I desired. I can enable termination protection on the EC2 instance. And I kind of mentioned termination protection as it relates to S3 earlier, where you can prevent people from accidentally deleting S3 objects. And the same is true of EC2 instances. You can enable termination protection, and that will prevent somebody from accidentally deleting or terminating an EC2 instance. In order to terminate the instance, you would need to actually disable the termination protection first. You can enable CloudWatch detailed monitoring, which is something I'll talk about later in the course. You can change the tenancy model. Right now, by default, it's shared tenancy, meaning that when I launch this EC2 instance, it's going to share the underlying compute infrastructure, the hardware, the server, with other customers. You could change that to a dedicated tenancy model if you wanted to ensure that your EC2 instances ran on a dedicated physical server that only your organization could use. If you're looking for a way to max out your credit card bill this month, then changing the tenancy model to dedicated is a great way to do it. Because it's not cheap. It's fairly expensive to purchase dedicated hardware, not just from Amazon, but really any cloud provider. Why would you want to do that, by the way? Why would you want a dedicated tenancy model? Well, you might have certain security or compliance reasons for purchasing dedicated tenancy. And then under the advanced details section, if I expand that, you'll see this user data field. And if you recall, user data is where we can configure a bootstrap script, which will run the first time the instance is launched. Now, if I were to stop the instance or restart the instance and start it back up again, it would not run the user data. The user data runs the first time the instance is launched. Okay, those settings look good, so I'm going to click on the Next Add Storage button. Here's where I can add EBS storage volumes to my system. Remember, EBS is the block storage system, and it is where we store our file system. That's where we store the operating system, our application files, all of our data, etc. And every EC2 instance has to have at least one volume called the root volume. In this case, it's a root volume of 8 gigabytes. And here's the volume type. Remember, I talked about different types of EBS volumes. The standard is the GP2 volume type. But I could also change it to the IO1, which is the provision IOPS. If I was kind of building a server with a heavy usage, highly transactional relational database or something where I/O was a major factor in terms of performance, then I would want to choose provisioned I/O. I could also choose the standard magnetic, which is the slowest storage, but also the cheapest storage. I'm going to leave it just as it is. I could also, if I wanted to, add additional storage volumes to the server as well. Next, I have the opportunity to add tags, and remember, tags is essentially metadata that I can associate with this AWS resource. I can use it to sort of categorize resources. I could use it for sort of cost allocation and budgeting purposes. I'm just going to give it a basic tag. Next, I can configure a security group. And this is probably one of the most important steps that you'll take when creating the EC2 instance, because the security group really determines the security perimeter around the EC2 instance. It determines what access is allowed into the server and out of the server. When you're configuring the security group via this interface, by the way, we're just configuring the ingress security group rules. So we're describing what data is allowed to come, or what access is allowed to come into the server. By default, with any new security group, all egress traffic is allowed outgoing. So we're going to create a security group, and in this case, I'm just going to create a basic server that we're going to access via SSH. So we want the ability to use an SSH client to terminal into the server remotely. And so I'm going to call the security group name SSH access only. And I'm not going to have a description. I'll just leave that. Well, I'll only allow SSH access. We'll provide a basic description. It's always a good idea. And then you see that the rule I need is already in place. We're going to allow SSH, which is port 22, and it's going to allow incoming access from this CEDAR address range, 0.0.0.0/0. I've mentioned this special CEDAR block range before. This represents the internet. And this rule basically says allow all SSH traffic from anywhere in the internet. Now, in practice, this is a bad idea. Don't do this. In a corporate setting, we would never want to allow SSH traffic from anywhere in the world to access our servers. We would want to, very carefully control SSH access to our servers. And in fact, later in the course, I'll show you a better way of dealing with this sort of security group rule. But for now, just for this hands-on example, we're going to use 0.0.0.0/0, or the internet. I could add additional rules if I wanted to, like if I wanted to allow HTTP access over port 80, I could do that here as well. You could add, a bunch of different rules. And it's pretty common to add several rules to a particular security group. In this case, I just want one rule. Okay, that looks good. So I'm going to click the review and launch button. This is an opportunity for me to review all the configuration settings. Notice that there's this warning message. AWS is saying, hey, you've got a security group which has a rule that's open to the entire world. That's just a caution. So in this case, yes, I know that security group is open to the world. And there are cases where, like if you have a public web server, of course it's going to be open to the world. But you should definitely heed these caution messages, and they should serve as a reminder so that if you inadvertently create a security group that's open to the world, then you could catch it here and go back and change the settings accordingly. Okay, I'm going to click on the launch button. One last thing that we need to do. We need to specify a key pair that we want to use to access this new Linux EC2 instance. Now, you're probably familiar with accessing servers or even your local workstation with a username and a password. Well, in the case of EC2 instances, you will use a username and a secure key to access a server. And a secure key is going to be much, much more secure than using a traditional password. It's way more complex. It's significantly longer. So it provides better entropy, better security. And so in order to set this up, what AWS will do is it will create a key pair, which consists of a public key and a private key. The public key is going to be stored by AWS and installed on the EC2 instance. And the private key is something that you will download to your workstation, to your local machine. That private key, you need to store that in a safe place. And it's got to be a place where you're not going to lose it. Back it up if you have to. That private key is your key to accessing servers. And if you lose that key, then you will lose access to your EC2 instances. And there's nothing you can do about it. If you lose access, then you're basically, unless you have some other way of getting console access to the server, you're basically going to have to just blow away, terminate the EC2 instance and start over again. So don't lose your EC2 private key. It's super important that you keep it in a safe place. Now, I already have a key that I've generated, and so I can choose an existing key pair. If you haven't created an EC2 instance yet, then you would want to create a new key pair. You'd give it a name, like my key pair, whatever you want to call it, and it's up to you. And then you would download that key pair. And again, you're downloading the private key, which is a .pem or .pem file. And you would store that on your system. I already have a key, and so I'm going to use my existing key pair. By the way, you don't necessarily need to create a new key for every EC2 instance that you launch. At least in this course, it's perfectly acceptable to create a single key pair and then reuse that key throughout the course. Now, in reality, in the real world, it's oftentimes the case that you have several keys that you're working with, and different teams might have different keys, and there's sort of different ways that you might come up with for partitioning the way you allocate keys within your environment. But here in this course, you can feel free to use the same key every time. I'm going to acknowledge that I do have this key on my system, and I'm going to go ahead and launch the EC2 instance. Now, it is telling me that my instance is now launching. It gives me a link so I can go back to the dashboard, and it will show that instance in the dashboard and show that it's launching. So every instance has an instance ID, this long alphanumeric string. It shows my instance type, the availability zone that it's launching the instance in, which is US East 1C, the public DNS or public IP address. It shows that it's currently in initializing mode. And if I look below, then I can see lots of different details about the instance configuration, the security groups that it's associated with, the AMI that I used, the key pair name, the private IP address. You'll learn in a future lecture that every single EC2 instance has a private IP address, and some instances may have public IP addresses as well, depending on what subnet they're launched into and how they've been configured. How long does it take for AWS to launch this instance? Well, it can take 30 seconds to a minute. And generally, after about a minute or so, you're able to log into the instance. Now, these are Linux instances, so they do tend to launch more quickly than something like a Windows instance. But we might be able to log into this instance right now. I'm going to switch over to a console terminal where I can use SSH to access the instance. And what I'm going to do is I want to SSH to the public IP address. And so I copied that public IP, and I'll type in SSH-I. Then I want to provide it with my private key, which is this PEM file. And then I'm going to log into the server with a username. In this case, I'm going to use EC2-user. Now, different AMIs might have different default usernames. The Amazon Linux AMI uses EC2-user as the default user on the system. If I was launching an Ubuntu AMI or Ubuntu instance, then the username would be Ubuntu. So if I was launching a Windows instance, then the username would be administrator. It's just something that you need to be aware of. Different AMIs may have different default usernames that you would use to log into them. I say EC2-user at, and then that public IP address for the server, and hit enter. And it's because this is the first time I'm logging in, it's trying to verify the authenticity of the host. I say yes, I'm sure I'm connecting to the correct host, and now I'm logged into the system. And I've got the login banner message from the EC2 instance. So I'm logged in, and I can run the shell commands and look at different parts of the system. I can install software. I can update packages on the system. If I do like a sudo yum update, I can update all the packages. So everything is available to me at this point. Before I kind of leave this terminal session, I want to show you something really interesting, which is that the EC2 instance, let me get to it here. The EC2 instance has available a metadata endpoint, and it's called instance metadata. The cool thing about instance metadata is that it provides applications and services that are running on the instance with an API endpoint that those services can query to learn more information about the EC2 environment. So what does that mean? Well, imagine you were writing a shell script on the server, and the shell script needed to know something about the EC2 environment that the instance was running in. Maybe the shell script needs to know the security group or the list of security groups that the instance is associated with. How would it find out that information? The operating system itself would know nothing about EC2. I mean, the Linux operating system, it's running in a virtual machine. It doesn't know if it's running on your desktop or running on an EC2 instance in the cloud. It doesn't know the difference. So the metadata instance, the instance metadata endpoint allows a script running within the instance to get more information about sort of like the outside world that the virtual machine is running in. And in order to query that instance, it's basically a web-based API that's exposed. I'm going to query that API using the handy curl command. Curl is like a text-based web browser. So I'm going to do curl and then hit that endpoint, which is this kind of funny looking IP address, HTTP 169.254, 169.254/latest/meta-data. This IP address is only available from within the EC2 instance itself. That's not something you can browse to on the internet. This is not a public IP address. This is a private IP address, a special sort of virtual API interface that's only available to these EC2 instances. And when I hit that API endpoint, you see it gives me other endpoints that I can hit. So for example, maybe I want to see the security groups that the instance is associated with. So I can hit metadata/security-groups. And when I do that, it responds back with the name of the security group that's associated with the instance, the SSH access only security group. This is a super handy feature. We use this all the time when creating shell scripts, especially like during the bootstrapping phase of the server. If we need to bootstrap the system in some way to, it's interacting possibly with other EC2 services, we can use this interface to learn more about the EC2 environment. Okay, let's jump back into the EC2 web console again. I have my server, it's up and running. I just wanted to show you a few additional things that you can do. If I click on the Actions button, I have my server selected, click on the Actions button. There are all kinds of different actions that you can take and do with this server. If I click on Instance State, I can stop the server, I can reboot it, I can terminate it. When I'm done working with the server and I want to get rid of it, delete it forever, I just click on Terminate. Now, if I terminate the server, it's gone forever. I can't recover it. There's no way to get it back. So if you need anything that was on that server, hopefully you backed it up first before terminating it. If I go to Instance Settings, I can change a bunch of settings. I can modify the IAM role. I can change that termination protection flag on the server. It can update the user data. I can get the system log, which can be kind of helpful if I'm troubleshooting a system and let's say I can't log into it for some reason. I could say get system log, and it will actually, if it's able to, AWS will log into the server and retrieve the system log essentially. I don't know that it's actually logging in. It might just be pulling it from the EBS volume, but it will retrieve the system log and display it for me, which can be very helpful for troubleshooting purposes. Okay, if I go to image, I can create an image, and I think I'll do this here shortly. What this allows you to do is it allows you to take an existing EC2 instance and turn it into an AMI. Turn it into a template which you can then use to launch new instances. You can think of it as a way of sort of cloning this system. Very, very cool feature. Under networking, we can change some of the networking configurations, which we'll learn about later. CloudWatch monitoring, we can change that service as well. And speaking of CloudWatch monitoring, if I look at the EC2 instance details below, there's a tab which says monitoring. If I click on that, I can get some telemetry from the cloud. The CloudWatch service it collects metrics and telemetry from AWS resources, and it will then it will essentially instrument that telemetry in the form of graphs. And so in this case, I can look at things like the CPU utilization. I can look at disk I/O. I can look at network bandwidth and so on. Very useful information, especially if I'm trying to understand the performance of my EC2 instance. I might use it for like capacity planning purposes. You'll find that many different AWS resources have CloudWatch metrics associated with them. Okay, so before I terminate this instance, let's go ahead and we're going to create an image from this. So I select create an image. I'm going to give it a name, and we'll call it my basic image, and we'll leave everything else the same. It looks just fine. And I say create image. Oh, that name is already in use. I must have used it before. My basic, I'm going to just call it my basic image 2. We'll go ahead and create the image. And it says your image is now pending. It'll take a minute or two to create an image. Generally, the time it takes to create an image is based upon the storage volume size of the EC2 instance that you're creating the image from. In this case, my EC2 instance only had like an 8 gigabyte volume, so very small. If I had an instance with 100 or 200 gigabyte volume, then it would take substantially longer. It could take anywhere from 20 minutes to 40 minutes, maybe even longer than that. It's definitely dependent on the EBS volume sizes associated with your instance. And once this image is available, then I can use it to launch new instances. So you just saw it became available. I could select it and say launch, and it'll immediately take me into the section of the launch process where I specified the instance type. Okay. So it's going to use that new AMI I just created to launch a new EC2 instance. And this new AMI is also private. You see the visibility is private. So this new AMI exists in my account. By default, it's not available to the world. Nobody else can use it. If I wanted to share it with other people, I certainly could do that. But by default, it's only owned by me and only usable by me. Okay. So a couple other things I'll just quickly mention on this EC2 dashboard. On the left-hand side, you see there are a number of links. If I want to see all the instances, I can get a list of them. Then I just click on instances. You can see I only have one instance currently running within this account. I can look at things like my reserved instances or dedicated hosts or capacity reservations if I've made any of those things. I can click on AMIs to see the images located in my account. I can click on volumes to see all the different EBS volumes that I've created. Right now I just have one EBS volume because that volume is associated with the single EC2 instance I just created. I mentioned in the lecture that you can snapshot volumes as well. Snapshot is like a way of creating a backup of a volume, which is really handy. I can look at the security groups that are set up on my account in Elastic IPs, which we'll talk about in a future lecture. I can also look at things like load balancers and launch and auto scaling groups and so on, all things that we will cover later on in the course. Let's go back to the EC2 dashboard. We have our single running instance. We're done working with it, and once we're done working with it, we want to terminate it. Now, sometimes students will ask me, hey, can't I just simply shut down my EC2 instance because I want to use it later on? Well, technically you can do that, but in general, we avoid we avoid shutting down instances when all possible. That tends to be a bit of an anti-pattern. It's better to terminate an instance and create one, to create a fresh one. And you'll learn later on in this course how we can do that very easily and using automated tooling. And so there's generally there's rarely ever a reason that we would want to sort of shut down and sort of save an instance for later use. We try to avoid that sort of reuse in this course. Okay, I have the instance selected. Let's go ahead and click on Actions, and we're going to terminate that instance. I click Yes, Terminate. And when I terminate the instance, it's gone. It's going to be gone forever. There's nothing I can do to get it back. Now, in this case, I created an AMI, so that's like, you can think of it as sort of a snapshot, a backup of that server at a particular point in time. But for all intents and purposes, this instance is now gone, and we will no longer be using it. I hope you enjoyed this hands-on segment and feel more comfortable working with EC2. It's a service that we will use extensively in the future lectures of this course.